Mr. Luis Vazzuria is Technical Pre-Sales Manager from GoodWe. Hi, Luis.
Hi, Jessica. Thank you.
Yes.
Thank you for the invitation, and it's a pleasure to be here with you.
Yeah, I would like to give you a view for our Mr. Luis presentations, pre-sales technical responsible of the Iberian and Greek and Israel markets, references engineer for utility scale projects at the EMEA region, also technical documents such as best practice guidelines, training and internal procedures, technical trainer for Spanish, example GoodWe Plus and international customers. And he's going to deliver with us GoodWe Empower Rooftop, an utility solar system with cutting-edge solution. Waiting. Are you going to prepare your presentations? Thank you.
Yeah, there we go. Thank you, Jessica.
Thank you.
Can you confirm that you see my presentation?
Sure.
Yeah, excellent. Well, thank you very much for the invitation and to be here with the panelists and the audience. It's a pleasure for us, for me personally speaking, to share with you all our knowledge and experience, and also the concerns that we may see. Maybe we can talk afterwards in the panel discussion about the markets and this new technology trend that is very interesting. But let's see during the presentation and afterwards. So for those who doesn't know anything about GoodWe, let me briefly introduce the company. GoodWe is an inverter manufacturer. We produce a string inverter. The company was founded in 2010 and successfully launched in the stock market last year in a really remarkable launching process in the technological stock market of Shanghai. Nowadays, we are more or less above 2,300 employees, and around, I would say that 80, I think we need to update because we are hiring, we are increasing the market, and we are doing very well. And more or less, we are 80 employees overseas, right? The company was founded in China, where we have two factories, so two production lines in Suzhou and Guangzhou, and two R&D centers where we develop the new inverters and new solutions for the market. Just to highlight, I'm not going to spend so much time here, just to highlight that in November 2018, GoodWe Europe GmbH was founded by GoodWe to manage and to take care of the European, Middle East, and African region, where we provide our solution and our support to the installers, EPCs, distributors, etc. Just to mention some market share, the market used to recognize us like the top three in Australia and Benelux, really rooftop markets. And also, little by little, we are conquest the market like Spain, Italy, or Poland, or Germany. We produce string inverters, as I mentioned. We develop string inverters in two different lines. String inverters, what we could say that is grid tie inverters. And the second line is the storage solution or storage inverters. The third line that we see here is the battery storage. This is a new line that we introduced this year. And we are actually in the marketing and launching process to the market about our own batteries, just to close the circle with the storage inverters. Today we are going to see briefly. I don't want to spend so much time in detail, just only to give you some tips and ideas about our inverters and also about the trend and the impact of this new technology modules. From the inverter side. Regarding the string inverters that we produce, we have the residential family, commercial and industrial family, and utility scale. I'm going to pay attention during this presentation about the CNI and also somehow some features that are in common with the utility scales. Just only a brief overview. We can see that for the CNI, for the commercial and industrial segment, we also in residential, but we have here this picture, this view of the CNI portfolio. we step in a very well, let's say, in a very well step, so very well defining all the portfolio. Then to give you the opportunity to select the proper inverter to cover your needs, right? When you design a PV system with the SDT generation 2 SMT with three MPP trackers, MT series with 4 MPP trackers, very well known in the market, both those two with more years in the market, and the new one that we started introducing this inverter during the last year, the HT series for the CNI, and also from 100, 120, and 136 kilowatt with between 10 MPP trackers for the 100 kilowatt and 12 MPP trackers for the 120 and 136 kilowatt. The next step is the utility inverters, also HT, but we work with 12 MPP tracker and the input is 1500 volts. Let me come back to the CNI portfolio. That is, I would say that both are interesting for the rooftop. I will explain you later on, but just only to give you some, to highlight here some points, right, of the portfolio. As you see, we don't work with the traditional and typical 1000 volts. We increase the voltage to 1100 volts that allows you to enlarge the string inverter. That means to reduce the investment in cabling or even in structure to optimize your rooftop design to what eventually the design impact in the capex. Maybe we can discuss later on about the economical impact of these features in projects. But thinking about the topic of this event, the new module technology, let me highlight that we say that we are compatible with the high current modules, the new generation of model. We have seen already from our colleague from Sunport Power that the portfolio, the roadmap portfolio, is coming from the 250 or 280, and to project the portfolio up to 700 volts. But this is a remarkable achievement. And this is a good news, actually. It's a challenge for the inverters manufacturer because we need to develop and to update the existing portfolio and also to develop a new solution, new inverters to work together, right, with the new models. But eventually, it's a very good news for the market in any case. In our portfolio, as we mentioned, as you can see here, we are compatible with in all the portfolio with the modules or with the high current modules, what we call new generation modules. In all cases, SDT generation 2, SMT, and HT. And for the MT, we have you can select proper models of this series to work compatible or to work with models with high current technology. Same topic for the HT, of course, just to mention that the inverter HT, no matter if it's the commercial and industrial version with the input of 1100 volts, but also the utility one, which operates up to 1500 volts, can operate up to 30 amps, what is really remarkable, would allow you to work what we are talking, the new generation PV modules that we have seen already in the market. Nowadays, we see models between 350, 80 to 500, but as we have seen in the previous slide, we expect in the market to the new evolution, the new generation of this new evolution of these new models, right? Above 600 volts. Actually, I think there is a model in the market already that is above 600 volts and more or less with current around 15, 16, 17 amps. What is, as I said before, is a challenge for any inverter manufacturer. In our portfolio, we can operate with HT up to 30 amps at MPP tracker level, what allow you to use those modules, of course. No matters if we are talking about the 182 wafer or the 210 millimeter wafer. One important point that we want to highlight, and I want briefly to stop here, is it's good to have the options in the market about the new models, right? But when we have to select an inverter that will work with high power modules, not limited to high power, but in general, with any kind of module, but specifically to high power modules, we need to consider seriously the thermal behavior of the inverter. I'm sure that the audience is know very well the derating concept. Briefly, is the derating is a programming that the inverter manufacturer, the R&D team, introducing the inverter and the processor to protect the inverter itself from overheating, right? From the and that heat or overheating comes from the current, right? The most sensitive component is the IGBTs, the transistor. IGBTs, isolated gate bipolar transistor, and is the component who is in charge, responsible to convert the DC direct current in alternating current, right? So it's the most sensitive one, and we need to protect that element to be overheated. That means to avoid the destruction, eventually the destruction of that component. The way to protect it is to sensorize the inverter with thermal sensor, but not only that, and to keep the control of the input. The inverter will control and regulate itself depending on the internal temperature, and what means the heat that the inverter is suffering inside of the case. Here we have the typical graph. In the left side we have the maximum AC power with respect to the nominal power, and on the bottom side we have the ambient temperature. Obviously, the temperature that we control is the internal one, that is higher than the ambiental temperature. But in this way, with this graph, we can compare different products, different inverters, different brands, etc. So here we see how an inverter from a competitor can operate up to in full load, what we consider full load, more than providing to the grid 10% up to 10% respect to the nominal power. And in such condition, the inverter can operate up to 20 Celsius degrees ambient temperature, and then decrease modify the output power of the inverter by controlling the input. That means and why is to protect the components. In our case, in all the C&I portfolio, we can operate under this low full load operation, including this 10%, supplying this 10%, additional 10% respect to the nominal power, up to 45 Celsius degrees. That difference that we see here is a huge amount of energy that during the year and year after year make a very big difference, successful or unsuccessful output or outcome of the project. Not only from the energy point of view, but also from the economical point of view, because what we are talking here is also about obviously the higher yield performance, what means eventually economical successful of that project. So it's really important to consider the derating and the thermal behavior of the inverter in any case, I would say, but especially in C&I and utility, and for sure in any area, I would say, but especially in hot areas or regions like Mediterranean, Middle East, and Africa. Just to highlight here that the portfolio, as I mentioned, is 45 Celsius degrees, the threshold of the derating. But we have one model, the MT 50 kilowatt, that can operate up to 50 Celsius degrees, what is a really relevant mark in the market. As I mentioned, how we control this is with sensor. We sensorize the inverters, not only the HT, all the portfolio are sensorized with different sensor, obviously, with internal to measure the internal temperature and also the humidity in the HT inverter. For those who doesn't know about the PID, this is also it became a hot topic, I would say that, in 2008 when some researchers and some PV modules brand well recognized in the market detect and announced in the market that there was a kind of physical phenomenon. First of all, I have to say that PID is a potentially induced degradation in the module, and it's a physical phenomenon that may occur depending on three main factors: the quality of the bill of material of the modules, the humidity of the place, and also the third one is the length of the string. We are going in a big trend to work with 1500 volts. I leave you there this reflection. We need to pay attention about the PID and the quality of the modules that we select, obviously. The humidity, obviously, we cannot do anything because that will depend on the location, but for sure we can do something when we select the modules and also the design. Obviously, to work with 1500 volts is an advantage because we can reduce the CapEx of the project, among other factors, by reducing the cost of cabling and even in the structure. But we need to pay attention that inverters are ready to provide a solution or a preventive option to mitigate at least the PID phenomenon. We have that option in our portfolio, also in the C&I portfolio, not only in utility, and here we show you. Regarding the technology, the telecom technologies, we developed different multiple communication technologies, Wi-Fi, LAN, 4G, Bluetooth, not only for singles, but also single units in PV plants, but also for C&I projects. Obviously, the most common one is 485 and PLC. PLC, although it's also available for the C&I projects, most common use of this technology is in utility plants. That's what allow you to reduce also CapEx, the telecom infrastructure, because we transmit the data, the inverter and the external devices like a CV3000 transmit the data through the power line. That means that you avoid installing the telecom infrastructure, cabling, pipes, etc., what is also a significant impact in the CapEx. As I said before, the 485 is the most common one in C&I projects. And just to, I'm almost finishing my presentation. For those utility projects, the HT series, we implemented in the HT series the reactive power compensation with the IGBTs, the new generation IGBTs, what allow the inverter to work in a fast reaction, and also to highlight this filtering 50% of the harmonics during the compensation itself, what is a really help to stabilize the grid, what for the grid operator and transmission system operator really appreciate, and most of the cases even request this kind of support. Just to give you some ideas of some projects, HT, MT in Turkey, and Istanbul, in Turkey as well, Netherlands, etc., and some in China. I didn't have enough time to update the cases. We have HT already in Europe, in Greece. We are installing in Spain, Poland, and Germany. And that's all. I feel that has been really brief. I feel that I fly, but I think it was more interesting the discussion and open to any kind of question that you may have.
Thank you so much,
Thank
Luis.
you very much.
Thank you for your presentations. Gracias.
De nada.